I want to explore the parent exponential function, but with a base that you may not be as comfortable with. We did study exponential functions, but what we did in class is we defined the base as just b to the power of x. What I want to do is I want to change that, because for calculus we need to think of it in a slightly different way, and here's what I want to show you. Typically what happens though is our exponential function has base e. E is an irrational number like pi, and it is used a lot in calculus and physics and so forth. So what I want you to do is think of your parent exponential function in terms of e, and that's going to help us with some other of our complex computations and analysis that we're going to be doing this upcoming year. Now you may be wondering, well, Stevenson, does that change the shape at all? Well, no, it doesn't, because it still meets the qualifications for a base, right? Remember, the base had to be, right? It had to be between 0 and 1 or more than 1, and e fits that requirement, or fits the greater than 1 requirement. So we're good. So what does this look like? Well, if you remember, any exponential will automatically be increasing, and then it will go through the y-axis at 1. And the reason that happens is because you're evaluating it at 0. Okay, so any base raised to a power of 0 is 1. So the parent exponential function of e to the power of x goes through the y-intercept. So let's go through and start analyzing some more of these characteristics here. Let's start with domain. The domain of any exponential function is all real numbers. Range. Now remember, an exponential function is asymptotic to the x-axis. So remember, what that means is it's going to get really, really close to that x-axis and get really, really close to an output of 0, but it will never actually achieve 0. The only way that happens is if you were to apply some sort of transformation to the function, specifically a vertical translation. So this range is 0 to positive infinity. It will never actually reach 0, but it's going to get infinitely close to 0. Let's talk intercepts. Because of its range, we now know there is no, or we can justify why there is no x-intercept. However, there is a y-intercept, and we can visually see it's 0, 1 right up here. Or you could see in my calculation right there, I knew that this would translate into 0, 1 as my y-intercept. Exponential functions, this is an always increasing function. It is always increasing in terms of its behavior.